Have you ever played on a swing? As you swing, you smoothly ride from the top of one end through the bottom to the top on the other side and back again. When you are on a swing, you move like a pendulum. The word pendulum is derived from the Latin pendulus, meaning hanging. A pendulum is a string hanging from a fixed spot with a weight. With a small push, it can swing back and forth. This rhythmic movement of a pendulum is also known as oscillation. Just like we can describe the motion of this car with speed, we can also describe motion of this pendulum with a term period. Let us find more about this with an activity. We'll take this plastic bottle, small rubber ball, thick cycle spoke and cotton thread. Let us fill this bottle with water to make it heavy. This piece of cycle spoke can be locked in the cap. With the help of a needle, one end of the thread is tied to the ball. Let us lock the other end of the thread in this slit. Our pendulum is ready. With a small push, it starts oscillating just like a swing. Let us watch it in slow motion. For this pendulum, period is the amount of time it takes from this point on the right, marked in green, all the way to the left, marked in red, and back again to the same point. It slows down after some time before coming to a complete stop. What could be the reason for this? I did not stop it by hand. For this rolling ball, friction with ground surface is responsible for slowing it down. For our pendulum, it is the resistance of air which is primarily responsible for the same. This is also known as damping. We'll discuss this later. Instead of regular stopwatch, we will use app in the smartphone to calculate period. It is difficult to measure time of one oscillation. So, we will measure time for 10 oscillations. That time can be divided by 10 so that we get time for one oscillation. Let us push this ball a little and let it swing for 2-3 times. Then we'll start the timer and count 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 10 oscillations, it took 9.4 seconds. That means for one oscillation, pendulum took 0.94 seconds. So period of the pendulum is 0.94 seconds. Ideally, we should repeat this activity many times. After 9 iterations, the period is approximately 0.96 seconds. Now we will reduce the length of the pendulum and measure period again. This time it is different. It is approximately 0.78 seconds. If we reduce the length further, the period is approximately 0.6 seconds. It seems there is some correlation between the length of the pendulum and its period. Let us mark angles as well as distances on this graph paper. We'll use it as a background. This is a pivot point marked in red. Pendulum is at rest. It is said to be in equilibrium. We will mark this with a black line. Angles are marked to the right side as well as to the left side. Angle between this red line and equilibrium position is 10 degrees. For this green line, it is 15 degrees, while for the blue line, it is 20 degrees. We can use these lines as a guide to set the initial amplitude of the pendulum. This line is at a distance of 10 cm from the pivot and this one at a 20 cm. Length of the thread is calculated as the length of the thread plus the radius of the ball, approximately 1.3 cm. The length of our pendulum is approximately 24 cm. Length is calculated from the pivot point till the center of the ball. This is the point where all the mass of the ball is supposed to be concentrated. Now let us repeat the same activity, but this time with some more data. We'll keep the length same but change the initial amplitude. Now it is 20 degrees. Now it is 15 degrees. Now it is 10 degrees. It turns out that for all the three angles, the period is almost the same. How about changing the length of the string? It is 24 centimeters now. Let us calculate the period of the pendulum. We'll repeat the same activity for different length. First with 20 centimeters and then with 10 centimeters. For 20 centimeters, the period is 0.9 seconds. For 10 centimeter, period is 0.63 seconds. It seems reducing the length reduces the period of the pendulum as well. How about the mass of the pendulum? Will the period change with change in mass? Let us take help of this hollow plastic ball. Mass of this ball is 4 grams. We'll keep the length of the pendulum as 24 centimeters. Period for this configuration is 0.96 seconds. Let us make a small hole with a hot rod. We'll fill the ball with sand and close the small opening with a tape. Mass of this ball filled with sand is 35 grams. With sand filled, the ball has a period of 0.98 seconds. Now let us remove the sand and add water with the help of a syringe. Now the mass of the ball filled with water is 25 grams. Period for this water filled ball is 0.97 seconds. With these observations, we can say that period of the pendulum does not depend on mass. It also does not change with initial amplitude of the swing. But there is more to it than just the length and mass. We'll discuss more about pendulum, like its applications, use of other mobile apps, use of formula to calculate period, and variations in the next video. Thank you.